Hello friends, welcome back to my channel Fitness Geek. Today we are building an entire architecture of this particular diagram. We will be using Terraform, we'll be building everything in Azure. So what we are doing is we are building an infrastructure for an entire application, the front end, the back end, the networking side, and the SQL database. What we are doing is we will be creating virtual network, a particular virtual network having few subnets, a subnet for front end, a subnet for back end, and we will make sure that the Azure SQL database, which is our main database, will only be accessible from backend, and the communication will happen via the service endpoint. So we'll be using the Azure SQL database firewall, and only selected networks would be allowed, which would be the subnet for the backend. So if you see this architecture diagram, you see the front end exposes our application, which can be anything like Node.js or Python, or like any application that you want to render via Azure App Services. So the resource we are using for front end as well as back end is the app service plans. We'll have an app service plan for front end, an app service plan for back end, and an Azure SQL database. We'll have keywords. We'll have keywords to store all our secrets, so we do not hard code any connection strings anywhere. So we'll create this entire infrastructure within a resource group, and once you are done, you can just hand it over to developers to start deploying their applications. If you look at the backend, the backend can be anything: Azure Functions or Azure Websites, Web Apps. So the goal here is to create a simple infrastructure for a simple three-tier application like a front end, back end, and the database, and to make sure that they are all protected. Let's write down what are the specifications. What are we dealing with here? So the communication, how it will travel, is the user will be only able to access the public endpoint of our front end. Our front end again is an Azure web app sitting on an Azure App Service plan. Azure App Service plan is a PaaS offering where you don't have to deal with the underlying operating system or infrastructures. You just create, it's kind of a serverless uh, take on creating app services. Then we need to protect our backend from direct access. So the backend in infrastructure should not be reachable via the public endpoint. So what we're going to do there is we'll have access restrictions in backend, so that backend only allows communication from the front end. So the front end will be inside a subnet, and that subnet will have access to the backend. Again, now the Azure SQL database will also be not allowed to be accessed at the public endpoint. What we will do is we'll take the backend subnet and allow that network to access Azure SQL database. We are using the service endpoint in this case as well. So this is the infrastructure that we are going to build. What we are going to use is we will be using Terraform. We have our Azure subscription ready, and we'll write all the resources, all the configurations in Terraform. So when I say these app services will be inside VNet, so there's a concept called VNet integration. So VNet integration is the part that will allow these app services to access resources within the VNet. As I said, backend service will allow communication via front end only. So these are the goals that we need to achieve. I have already written the code. I'll push this into a GitHub repository. I'll share the link if you want to access this. And right now I'll try to deploy these things, and I'm sure there will be some hiccups, some errors somewhere. We'll fix that on the go. I'll make sure that I do not just skip those parts. The most important part is all the communication here is happening through the Azure backbone network, which will give you uh, you know good throughput, and you'll not have those NAT port exhaustion issues, which is a common problem in all those public endpoint enabled applications. So this is all we want to achieve. All looks good. Let's dive into our Terraform. So if you see my structure of my Terraform, I've got a Terraform file for each component. I have a file for VNet. So I'm creating a virtual network, creating a front end subnet. I'm creating a backend subnet. This is the app service plan, a front end app service plan, a backend app service plan. Both are Linux, and I'm just using the B1 tier. So I missed the depends on. So depends on make sure that there is a flow in which the resources are created. For example, if there is a resource that is dependent on a storage account, but the storage account took longer to create, then that particular resource which was dependent on storage account will fail because it cannot find the storage account. Or in this case, if the VNet was not ready, we will have trouble in VNet integration. So we want to make sure that first the VNets are created, the subnets are created, and then the app service plans and the app services get deployed. So I'm just adding those. Azure website is like just the web apps on top of our app service plans. This is our front end web app. These are the minimum configurations that I have used. uh, Obviously when we go into a real project, there will be a lot of changes that you would like to do, but these are Node.js basic apps ready to be used. This is our function app. So as a backend, I thought let's just create function app. So app service plan allows you to create web app or function app in it. So I'm creating the function app and then the VNet integration. This bit here, the Azure RM app service virtual network Swift connection. This bit is what integrates our app service inside the existing VNet. Let me change that. That is our front end dot. Where is the ID? Okay, so that is done. Let me save this. Oh yeah, it should be subnet. That's a mistake. Cool. Let's add the depends on. I missed to add the depends on, so let me add. So this would depend on, obviously, like if the subnet is not created, it will not be able to complete this part of the code. So this part of the code should wait until the subnets are already created. So we have added that, saved, all looks good so far. If you see this IP restriction on the function app, so it only allows communication from the subnet. So the subnet within which the front end is sitting, the communication will be allowed from that. And yeah, this is our database. We are going to deploy an Azure SQL database. So first we'll create a random password resource so that we can have a password for the SQL admin. If you see this resource, MS SQL, Azure MS SQL, I am passing the password from the random, so I do not expose anything. This is the virtual network firewall rule for the database server. Again, this will also depend on the server. So all is looking good. This is our MS SQL server. That's the name, version, administrator login, password. We are not hard coding anything. Azure AD administrator also. You can, you can find the object ID that you want to pass. So I'm making my current Azure AD user as the AD admin. MS SQL Server. Yeah, it should not depend on database, but the SQL Server. And this is our, so so I'm building a connection string which I'll store. So this is a Python connection string for our Azure SQL database. I'll store this inside this particular key vault. So I'll create a key vault and then I'll store the Azure SQL password and the connection string as Python. We can build that like for anything. If you want to build for a .NET or like ASP.NET, or if you want to build it for just a JDBC kind of a connector, you can build that and store it. In outputs, we are out getting taking the output for our front end and the back end, and obviously the main TF has got our resource group and our Terraform provider block. I mean the Terraform block which has all the providers, and a variable just for the location. I mean we could do a lot of things in this, but I have kept it a bit simple. Everything is saved. Let me do a Terraform plan. Reference to undeclared resource. Okay. Outputs.tf. A managed resource web app has not been declared in the root. Yeah, this output that I'm trying to fetch is just a URL. So this is also I'm creating that value. I'm using the web app name and then dot azure websites.net, which is the URL or the extension for all the app Azure app service websites. Let's see. Oh yes, so I added an FE prefix. So it should be FE, and yeah, that should be fine. The database, I've saved it. Let's go ahead. Let's see if we have any more errors. We will fix that. Another one, a managed resource has not been declared in a SQL database. I think I made a mistake there on the depends on. Let me check. So I'm troubleshooting on the go. So I'm not just having a simple demo uh, already all set. I just press deploy and everything gets deployed. But I'm fixing errors on the go. So you can see how we fix errors in Terraform. So it told us where that exact issue is. And what is the mistake? Okay, Azure SQL is actually an MS SQL server, not the database. So I should change that. Yes, so it should not be MS SQL database, but it should be MS SQL server. And the server name, this is identifier for Terraform. And yeah, let's run that again. Let's see what error we encounter now. Amazing. So all the issues have been fixed. All the depends on and calls that we added are fixed. 20 to add. So if you see the plan, 20 to add, 0 to change, 0 to destroy. So let's run our Terraform apply with auto approve. Auto approve will make sure that we do not have that approval stage, so everything gets deployed. Let's go to resource group. Currently we don't have the resource group. Once our Terraform gets completed, we'll have a resource group and all the resources. So let's see what it's doing. First it creates the random password resource. It has started. If when you run it for the first time, always check what it's doing. It will give you more in-depth idea of how it creates things. It's still creating app service plan. It will take some time. Obviously it's creating all the resources. Like Terraform also hits the same APIs that Microsoft makes it available for us, the ARM APIs. So yeah, everything goes via the same way and it gets created. And I don't want to skip this part, Let this part run. If you want to skip, you can, definitely go ahead. But I will not skip this part of the deployment. Let's keep it running. It might be boring for you, so if you don't want to, just let it run or read what it's doing, you can skip to the next part. It's going all right so far. Let's see if it finishes everything. Okay, we've got a couple of errors. Checking the presence of existing secret SQL admin. Checking the presence of existing secret. So this is the part that has failed is when you create secrets in our Azure Key Vault. So let's refresh this. If you see, the resource group is created, all the resources are in there. Let's see the Key Vault. Key Vault is all right. Okay, that looks all right. Let's try to understand the error. Error 400 code forbidden. So it probably does not have secret get permission. Okay. Okay, so let's see why the access policies are not getting implemented, or is it just missing that? So we have our access policies here. If you see, get, backup, delete, all those permissions for the secrets. The first policy and the second one is just making sure the Azure CLI has permissions. So these, yeah, okay. So the point where we write these secrets in the key vault needs to wait till the access policies are implemented. So let's add the access policy bit as it depends on. So it waits till the access is actually provided to the CLI. So access policy dot key vault policy dot policy, and this should do it. So now what the block that we added depends on, we just made sure that the access policies are created first, and then we try to push our secrets inside the key vault, and this should do the trick. This is why the order of execution or the order of deployment is very important, because you cannot create something unless you have the permissions. So you need to make sure that the permission block or the permission bit is implemented, and then you actually do any read or write or create. So that you will encounter this in lots and lots of resources. When you create some resources, you'll always have these kind of scenarios. Right, looks right. Let's just do the Terraform apply. I'm hoping this time everything will be fine and the secrets will be created in our key vaults. Let's just wait for a couple of minutes. It should almost be done. The database getting modified. Secret done. Okay, so if you see the apply is complete, 2 added, 3 changed, 0 destroyed, 0. Yeah, the Indian accent coming in. So yeah, if you see the outputs, we have got the backend URL, the front-end URL, and just the resource group ID. Let me use the backend URL. So if you remember, we have got access restriction on the backend URL. So if I just copy and paste it, this is the public endpoint. I should not be able to reach it. I should get a 403 successful. So it is forbidden as expected. And the front end URL. Here the access is allowed, the public endpoint, because this is our front end. So we'll just copy it. Oh, come on. This is the front end. And let's just deploy that. I mean, just paste it here. And yeah, that's it. So our front end resource is ready. The backend resource is ready. All the resources deployed successfully. The VNet. Let's look at the VNet. The subnets, the backend subnet, the front-end subnet, delegated to server farms, which is which just means that your Azure App Service or Azure website is delegated, it's been integrated, and the service endpoint for Microsoft SQL, which is like a SQL, which it allows communication via the subnet. So you need to enable those service endpoints. Let's go to our front-end website. Let's look at the networking side. Outbound traffic, VNet integrated. Subnet detail, front end subnet. This is good. Let's go back. No access restriction for front end. This is the backend. I've got a backend function app. It can be anything, You can have like Swagger APIs inside Azure Web Apps. So you can do that. Networking looks good. The access restriction, allow from front end only. So if you see, I've got this warning that Microsoft.web service endpoint not found on subnet. So this is a bit that we missed. So the front end subnet, we needed to enable the service endpoint for Azure Web App, which I think we missed. Let me go to the front end subnet. Yep, the service endpoint is missing. Let me add the service endpoint quickly. Yeah, let me just copy this. And yeah, for front end it would be web. Let's go to the error, Microsoft.web, and awesome. That should be enough. Let's just save it and plan again. It's always good to run the plan before you apply. Even if you know what the changes would be, it's always good to run plan so you don't push any unwanted changes. Okay, so let's now run the Terraform apply, because 0 to add, 3 to change. One of the changes is the service endpoint. If you take a look, yeah, so all looks fine. Let's just apply that. Still applying. Should not take more than a minute now. Let's just wait. Let me scroll up to show you the changes happening. Anyways, the change is complete. Applies completed. Let me refresh this. See, the warning sign is now gone. That means the front end app, or the front end subnet, has got the service endpoint enabled. All our resources are created. The two app service plans, the front end, back end, the individual apps in the app service plans, the function app, the SQL DB. If you look at the SQL DB's configuration, selected networks and communication allowed only via the backend subnet, and state is ready, endpoint enabled. All looks good on the SQL database as well. So I think we have completed all the entire deployment as we had in our initial diagram. So this is a full-fledged three-tier architecture deployed via Terraform in Azure. Any changes to these can be done, no problem. We will do a part 2 of this where we will add logging. So yeah, stay tuned and keep following this channel. Everything is secured. Very nice. This is what we wanted. Thanks, guys.